Hey everyone, it's Bradley Bush again with another algebra video for you. Today we're talking about the natural exponential function. Kind of a fun little function. Our to-do list today, first we'll give you the definition of the natural exponential function, which, by the way, is e to the x, just in case you're wondering. And then second, we'll just kind of talk a little bit about it because I kind of want you to see a big picture, how it works, how the definition works, because it's kind of fascinating. I will also put timestamps by these two options so that you can skip ahead if you want to. Here's the definition of the natural exponential function. So this is a number, e, really. E is a constant. It's a transcendental constant, kind of like pi, that occurred so often in natural applications of mathematics that they decided they should give it a name like they did to pi, because it's much easier to say e than it is this forever long number that never ends. So this is the definition of e. It is 1 plus 1 over n raised to the nth power. And we let n start at 1, and it goes to infinity. So if n starts at 1, and then 2, and then 3, and then it just keeps going on and on and on and on. As it gets bigger and bigger and bigger, this number on the left gets closer and closer to e. And as n goes to infinity, we get e. And that's what we have. Our function, f of x equals e raised to the x, or e to the x. And here are the first few digits, first 9 digits of e right here. 2.718281828. And it keeps going on and on and on with some crazy numbers. So let's kind of dive into the n and how it gets bigger part, because I think that really helps you understand what's going on. So what if we let n be 1 and we computed our formula here? 1 plus 1 to the n, which is 1, all raised to the n. So that gives us 1 plus 1 to the first power, which is just 2, right? So if n equals 1, our expression for e just equals 2. That is not 2. 2.71828 blah, blah, blah. That's not just 2. It's got a whole bunch of other stuff by it. So let's keep going. Let's make n get bigger and see how it changes. So if n is 2, we have 1 plus 1 over n, which is 2, raised to the n, which is 2. So 1 plus 1/2 is 3/2 squared is 2/5. That's closer. We've added a quarter there. And notice when it goes 3, n equals 3, 1 plus 1/3 to the third power. That's 4/3, which is 2.37. We're still not 2.7, but we're at 2. Notice as we go down, as n gets bigger, notice the first number here, 4, 4, 5, 5, 5, 5. And then once we get to 10, what happens when n equals 10? 2.5937. We're getting closer to 7.1. But this isn't getting closer fast enough. So let's let n get bigger really fast. Let's do n equals 100. So we have 1 plus 1 over 100, all raised to the 100. That's about 2.7408. Hey, look, there's a 7. So check that out. We have our first digit there at 100. Let's keep going. 1,000. If n's 1,000, 1 plus 1 over 1,000 raised to 1,000. If you plug that into your calculator, you get 2.71. Check that out. We've got 2 digits of accuracy. Now we've got 2.71. If we went 10,000, that's a pretty big number, right? N's 10,000. 1 plus 1 over 10,000, all raised to the 10,000. 2.7181. We've got our third digit of accuracy at 10,000 there. How about 100,000? 100,000 is a pretty big number. Let's try 100,000. 1 plus 1 over 100,000 raised to the 100,000. That gives us 2.7182, and then it goes 6. So we've got 4 digits of accuracy. 4 digits there, and we had 3 digits back here. 4 digits of accuracy at n equals 100,000. How about a million? Let's try a million. You can see that the bigger the number is, the more digits of accuracy we have here, the more correct digits we have. And we get closer and closer to this number, which we call E. So how many digits do we have here? 2.71828. Check that out. 2.71828. We've got 5 digits of accuracy. We've got both of these right there. How about 10 million? How close are we at 10 million? 2.71828. 1. We gained another digit. So there we've got 6 digits of accuracy. Do we get another one at 100 million? 100 million. So 100 million isn't a super big number. I mean, I wish I had that much money, but it's not really that big as far as numbers go, right? 1 plus 1 over 100 million raised to 100 million. That gives us 2.78281. Nope. We're stopping at the 1. Notice we're closer than we were at the last one. This was a 6, and this is a 7. And we really want an 8, so we're not that far away. We keep going, but we'll get there. But you can see that if you let n, if you take our expression in our definition right here, 1 plus 1 over n, all raised to the n power, and you let n get really, really big, you end up getting E, which is pretty awesome. Kind of fun. Hope this was helpful. I hope you understand really how E works and how we derive the constant E. If you enjoyed it, follow the channel, give me a like, and thanks for watching.